Good afternoon, this is Schweitzer, and this is a little make it stick for strong acids. Now, the point of this is to put yourself in a testing environment to see if you can answer this topic without checking your notes, or if you're planning on using a note card for your eventual upcoming quiz, do you have that with you? Okay, so take a moment, pause the video, and take about 5 to 7 minutes and see if you can complete this little practice self-check. Okay, let's go over the answers to this little practice. So it says this is omega-6 strong acid. So I have a situation here. Grab a pen. All right. We work. Okay, so now it says we have this acid here. It's a couple things here. HI is a strong acid. And it's only 4 strong acids. You got to realize there are 6 strong acids. HI, HBr, we have HCl. These are called non-oxy acids. And we have 3 strong oxy acids. H2SO4, HNO3, and we have HClO4, sulfuric acid, nitric acid, and perchloric acid. Write out the hydrolysis reaction. Okay, so every acid produces H plus ions in the same fashion. And it reacts with water. Water is a liquid. This would be aqueous. And so it has a concentration. The water does not have a concentration. Produces H3O plus ions. Of course, this is also going to be an aqueous solution that has a concentration. The larger that concentration is, the more acidic you are. And then we have I negative, which is kind of a along for the ride here. All right, draw a model of solution. Okay, so I don't know like proportionally if I'm going to be able to draw out the exact concentration. So that's not of I'm not comparing concentrations here. So how many I add is kind of up to me. It's a strong acid, so it's 100% product favored. All of its products. So I can draw H plus or H3O plus interchangeably. So this, I could draw that, or I could draw this, H3O plus. Both are completely acceptable. And I might leave it like that. Calculate the pH. Okay, again, we've done some of this already, so I'm not going to go through the whole thing. For a strong acid, just the negative log of the concentration, which is 0.75. And there we go. Solve all the answer for that. So grab a calculator, and negative log of 0.75 is 0.12. So a pretty low pH, 0.12. All right, upcoming, so that's the main concept here, but the next half of this chapter is going to start relying a little bit on a few things from the past chapter of equilibrium. So let's kind of just talk about this a little bit, see if you could give it a try. Hopefully you tried it and see what you can do. Write equal expression for the hydrolysis reaction above. Okay, so that's pretty straightforward. The K value, we might call it Kc if you'd like, just using concentrations, is product concentration, so H3O plus, and then we have I negative. And then the bottom is concentration of HI, and then we don't include water because it's a pure liquid. There you go. This particular reaction, whenever we're dealing with a hydrolysis reaction, and they're almost always the same, we have a special name for this. Is called Ka, and that's I've often thought maybe they should do it KHA, hydrolysis acid, or something like that, or acid hydrolysis, KAH. It's always about hydrolysis, and that's it. Okay, so what can you say about the size of K? Is it going to be big, small, medium? Well, we only have products here. So everything is going to be shifting from here to here. So this thing is going to be super huge. Now, at that point, a Ka value for a strong acid is either not given as being too big, or it might have something. You might find some place that might list it like 1.0 e to like the 80th. which means this thing is almost completely gone, is just basically gone to product. So that's why we only show products in our beaker, because it's gone to products. It goes to completion. Thank you very much.